So on this question, we want to determine whether Rolle's theorem can be applied to this function f of x equals x minus 2 times x plus 3 squared on the interval from -3 to 2. If it can be applied, we want to find the value of c guaranteed by the theorem. So let's take a look at Rolle's theorem and look at the conditions and the conclusions of this theorem. The Rolle's theorem says, let f be continuous on the closed interval from a to b and differentiable on the open interval a to b. If f of a equals f of b, then there is at least one number c in the interval from a to b such that the derivative is equal to 0. So let's see if this function meets the conditions of the theorem. So the first condition is that we need our function to be continuous. Our function is x minus 2 times x plus 3 squared. This is a polynomial function and it is continuous on all real numbers, so it is also continuous on this interval from -3 to 2. The next condition is that our function needs to be differentiable on the open interval. Since this is a polynomial function, it will be differentiable. It is differentiable over all real numbers, but for our purposes on the interval from -3 to 2. And then the final condition is that we need f of a to equal f of b. So this is a condition that we need to check. So let's calculate f of a. F of a would be f of -3. That's -3 minus 2 times -3 plus 3 squared. That's -5 times 0 squared, and that's 0. Let's check f of b. F of b is f of 2, and that's 2 minus 2 times 2 plus 3 squared. That's 0 times 5 squared, which is also 0. So the third condition is met, that f of a is equal to f of b, which is 2. So that leads us to the conclusion of this theorem. The conclusion is that there exists a c in the interval from a to b, in the interval from -3 to 2, such that the derivative will equal 0. The derivative at that value of c is equal to 0. So to find that value of c, we need to calculate the derivative and then create an equation by setting that derivative equal to 0, and then we'll solve for the value of c. So let's calculate the derivative. Our function is f of x equals x minus 2 times x plus 3 squared. I'm going to calculate the derivative in this format, in this factored format. And because I'm leaving it in this factored format, I'll have to use the product rule to calculate the derivative. So I'll do the first times the derivative of the second plus the second times the derivative of the first. And I'll simplify to get x minus 2 times, here I'll use the chain rule. And the derivative there is 2 times x plus 3 to the first power, and the derivative of the inside is 1. Continuing, I have x plus 3 squared, and the derivative of x minus 2 is 1. I'd like to leave this in factored form. I have a common factor of x plus 3, which I'll factor out. And if I factor out that common factor, what's left is this factor of x minus 2 and this factor of 2. I have 2 times x minus 2. And if I factor out one of these two factors of x plus 3, I will still have a factor of x plus 3 remaining. So I have x plus 3. In the parentheses, I'm going to use the distributive property and combine like terms. That gives me 2x minus 4 plus x plus 3. And I have 3x minus 1. So I've calculated the derivative and written it in factored form. So let me just remind you what we're doing here. We're trying to find this value of c that is guaranteed by the theorem. We've calculated the derivative, and now we want to create the equation where we set the derivative equal to 0 so that we can solve to get that value of c. We'll set our derivative equal to 0, and that gives me x plus 3 times 3x minus 1 equals 0. And since I already have it in factored form, I'm going to be able to set each one of these factors equal to 0 and solve. I can subtract 3 to get x equals negative 3, add 1, and that gives me 3x equals 1. Divide by 3 to get x equals 1/3. And these are my potential values of c. But going back to the statement of the theorem, you can see that c needs to be in the open interval AB. C needs to be in the interval from -3 to 2. And since x equals -3 is not on the interior of the interval, we don't count that as the value of c. We're only going to count the value of c to be 1/3, which is on the interior of the interval. So just to be clear graphically, we have -3 to 2 being our interval, and we found this value where the derivative is 0 to be -3 and also 1/3. And the theorem guarantees that there'll be a value of c inside the interval, on the interior of the interval. And so this is our value of c. For this question, the product of two positive numbers is 588. Minimize the sum of the first and 3 times the second. I'm going to let my first number be x and my second number be y. And from the first statement, we know that the product of these numbers is 588. xy equals 588. And the expression that we want to minimize is the sum of the first and 3 times the second. We want to minimize this expression, but right now there are too many variables in this expression. I'm going to, instead of calling this minimize, I'm going to call this the sum, and we're trying to minimize this sum. So there are too many variables in this, so we're going to use our secondary equation, x times y equals 588, to reduce the number of variables in the equation. I'm going to solve for 1. You can either solve for x or solve for y. I don't think it matters which one. So take your equation, xy equals 588, and let's solve for Let's solve for y. I'll divide by x, and that gives me y equals 588 over x. Then we're going to substitute this into our equation that we want to minimize. So this gives me the sum equals x plus 3 times 588 over x. Let's simplify that by doing 588 times 3. So 588 times 3 is 1,764 over x. And since I'm going to be doing some calculus on this, I'm going to change the format to x plus 1,764 times x to the negative 1. So now I'm going to calculate the derivative and use the process to find the minimum value. I calculate the derivative, that gives me 1 plus 1,764. The derivative of x to the negative 1 is negative 1 x to the negative 2. This is 1 minus 1,764 times x to the negative 2. I want to find my critical numbers by setting the derivative equal to 0. I can move the variable to the other side. That's 1,764 x to the negative 2 equals 1. And I can write this as 1,764 over x squared because of that negative in the exponent. I can solve this by multiplying both sides by x squared. And that gives me 1,764 equals x squared. I'll square root both sides. And when I square root both sides, let's see what I get. The square root of 1,764 is 42. We get a plus or minus 42. And going back up here to the problem, the original problem, it says the product of two positive numbers, so I can eliminate the negative number from our discussion. We're only going to focus on a positive 42. And we want to verify that this 42 is actually a minimum value by calculating the second derivative. So our first derivative was 1 minus 1,764 x to the negative 2. I'll calculate the second derivative to be negative 1,764. The derivative of x to the negative 2 is negative 2 x to the negative 3. 2 times 1,764 is 3,528 x to the negative 3. And I'm going to test that value of 42 into the second derivative. So we get 3,528 times 42 to the negative 3. This is a positive times a positive, and so we get a positive value. When the second derivative is positive, that tells us concave up. And because we're talking about a critical number, that critical number has a horizontal tangent line. And for concave up, those two things combined tell us that 42 will be a minimum value. So we know that 42 is a minimum. So we want to find the other number as well. And over here we have that y is equal to 588 over x. So 588 divided by 42 gives us 14. So our two numbers, the first number is 42 and the second number is 14. These numbers produce a minimum value for the expression x plus 3y. Thank you for checking out my videos. Have a great day.